Hey everyone, Mr. Voppel here. Wait, was... Oh, sorry, my finger was on the camera. Anyway, Mr. Voppel here. As you can see, I'm here in my secret underground bunker, waiting out until the current apocalypse is over. Wherever you are, hope you're safe. Keep washing those hands. I should have enough sugar packets here to last me forever. So we're good to go. I've gotten a lot of questions about how to do these problems with net force. It's a little confusing. So let's tackle an example and I'll give you a quick tutorial. Let's get started. So I've got right here one of our carts from class. Just like we've used before, our track's right here. This thing can move back and forth on the track. And remember, we said there's no friction, it's frictionless. So whenever I do this, it moves at a constant speed. We know that. So here's our cart, and here's what we're gonna do. If you needed to right now, you could draw a free body diagram of this cart. And actually, why don't you go ahead and pause the video and do that. All right, let's draw this thing. Time to draw a free body diagram of the cart. Well, the first thing we need to do is we need to start identifying what are the forces. What are the forces acting on the cart? Well, you might say, hey, there's some sort of downward force from the earth pulling down on it. We call that gravity. We can label it Fe for earth or Fg for gravity, but it's the force of the earth on the cart. So now on our list off to the side, we're going to write that. Force of earth, the object, on the cart. Excellent. We've got one force. What other forces are there? Well, you might say, hey, isn't there some sort of upward force pushing up on the cart? Yeah, just like those other examples we've done, the track or the table's pushing up. So let's label this, say FT for track or table, either is fine. Now notice how I'm doing this. I draw an arrow, and then I label it with a letter, force, F for force, and then a second letter, T for track or something else that helps us. That's just to keep it organized. So then we go off to the side, and we need to add that to our list of forces. So let's do that. FT, tell me what it is. Force of track, you could say table, either is fine. On what? On the cart. Notice that all of these are written as force of blank on blank. It's a free body diagram of the cart. So all of our forces should be on the cart, not on anything else. Well, hey, what other forces are there? There are no more forces. Remember, we need to know when to stop drawing free body diagrams. That's it, just these two forces. Nothing else, we're ready to go. Okay, so hopefully we got that down. Easy enough. The force of the earth pulling down on the cart and the force of the table pushing up. Well, hey, actually, we can get a little bit more information here. Why don't we get some numbers? We haven't done that yet. So we can figure out how much force the earth is pulling down on the cart. That's just called the weight. Weight is the force of a planet pulling on an object. And we can measure that weight using this spring scale. So if I take the spring scale and I hang it right here, I can read what the weight is. Okay, so now I brought it closer so hopefully we can see. See right here, this is the spring scale and the cart is just hanging on it. And so what that means is now this spring scale tells us what is the weight of the cart, because weight is just the force of the earth pulling down on the cart. So the spring scale reads it. And what we can do is I'll bring it close here, see if you can read for yourself what's the weight of the cart. So we see that it's right between 4 and 6. It's at that middle line, which should be 5. There you go. So the cart weighs 5 newtons. We can put that on our free body diagram now. So when we add the number of a force, the amount, to a free body diagram, all you need to do is find your arrow. Remember, that was the force of the earth on the cart. It was the force of gravity. And that's the weight we said was 5 newtons. We read it off our scale. 5 newtons. There we go. See that all I did was I just added it here on my free body diagram. So you can do the same. So hopefully we feel good about the free body diagram now. Let's see what happens if we add something new. I have right here a fan. And what I'm going to do is I'm going to turn this fan on. That feels great. Can you feel it? So I'm going to put the fan on top of the cart. Here we go. And right now I'm holding it. My question is, what do you think is going to happen when I let go of this cart? Let's see. Oh, look at that. It takes off. It speeds up. Moving here to the left. Woo! So, this fan, and here's what I can tell you, is on its highest setting. And let's say on its highest setting, it provides a force of 2 newtons. 2 newtons of force pushing on this cart. And what direction is it pushing? Well, it's pushing this way, right? Because which direction does it push the cart? Pushes this way. So let's add that force to our free body diagram. So let's update our free body diagram. What changed? The force of the earth did not change. It still weighs 5 newtons. And the force of the table is still the same, still sitting on the table. But we have a new force. Like we said, now we've got a force of the fan. And what direction does it push? We said the fan pushes to the left, so we should draw an arrow to the left and then label it. We'll call it FF for force of fan and add it to our list. Force of fan on the cart. Excellent. So there we go. Now we know how much this force is, don't we? How many newtons? I said that it was 2 newtons. So add that in there, 2 newtons to the left. Well, there you go. That's it. Okay, so now that we understand drawing the free body diagram of this guy, in the next tutorial, I'm going to show you what to do with net force. All right, see you soon.